So Wayne, how do you feel about going?
Well, results are still due in, of course.
For everyone.
I think it's going really well. What about yours?
I think mine's going brilliantly.
Well, that's good.
So and I've forgotten they don't know, do they?
You know, I always do. I always assume they know, but
I always do, but they don't.
say on a secret.
You ready? So, you know, I've been doing tests recently. We had a psychological one and a speed one. This one's a field one.
Yeah, and it takes place in a field.
You've got it.
I've got it.
Yeah, you got it. So what they do, right? You each get a field.
You each get a field. Mine's just down the road.
And we're in mine currently.
Oh wow, yours is.
Mine's got a roof and everything.
It's very square.
It's lovely. Anyway, they cover your field in landmines. Isn't that nice?
It's nice. It's nice.
It's nice. So what you have to do is you have to find all the landmines. You don't know where they are.
You don't know how many there are either. You never
No.
know if you've found them all or not.
You have to find them all. And they test you at the end. You walk your own field, all the way along. And if you don't blow up, good. If you blow up, if you failed it.
Then you have to look for a new job because you've been fired.
But you don't, because you've blown up.
That is the bomb.
So it's a win-win for everyone, really.
Yeah.
How do you do it?
Well, I took a mathematical approach. I thought you would really appreciate that in
okay.
particular. And so I used congruent triangles. I found out that they were equidistant. Lovely word.
Lovely word.
So I found out they were equidistant, pinpointed their exact coordinates on my field and just dug them up.
Oh,
What about you? What did you do?
I did it by eye.
Well, how did that go?
Well, I went to the edge of the field, right? And do it with me.
Okay.
To the edge, and I went, okay, I reckon there's a mine there,
There.
and there,
And
there,
there,
and there,
and there,
and there, and there,
and there, and there.
and there, and there, and there, and there, and there, and there,
Over there.
and there.
And there.
Yeah.
Oh, do you think you got them all?
Oh, I reckon there's a few daffodils in there, but
Can't be helped.
no, I can't be helped, so my field is completely clear of mines and daffodils.
So you're a bomb disposal team and a gardener.
All by myself.
I would hire you.
Today. But Wayne, I'd quite like to hire you.
Oh yeah, what for?
Yeah. But teach me the congruent triangles method. I think that might be handy in later life.
Yep. Well, teaching might be handy for me in later life, you never know, so it's win-win really, isn't it?
Really. Okay.
So, I'll teach you.
Alright.
Firstly, what I'm going to do is I'm going to draw you my field, which is just down the road.
Yeah.
You might even have seen it earlier.
I might have done. You might have done.
So it looks a bit like this.
It's not very square, Wayne. It's more rhombus.
It is, and that's in fact exactly what it is. I haven't drawn that by mistake. It is actually a rhombus.
Oh, wow, okay.
So what I did is I started off by labelling the corners.
It's a good
A,
start.
B, C, and D.
Right.
Then I put a few arrows on it. There.
Yeah, okay. So, what the arrows mean?
Well, it means if this line's been really good, it gets upgraded, it gets an arrow on its badge. And this line, well, that's nearly the citron symbol.
Wow, is that really it?
No.
Oh.
No, they don't have jobs or cars.
It's a sad life for a line, really, isn't it?
Yeah, I mean, Flatland's not a nice place anymore.
It's not. It's not.
So what it actually means is that they're parallel.
Okay.
This line is parallel to this line, and if this diagram was much bigger and there was another line with a
Sure.
single arrow on, that would also be parallel to those two.
Ah, what about the double lines?
That means that they are parallel to each other, but because there's two, not one, they're not parallel to the one with one.
That makes sense.
Yeah.
Okay, wait, so I've got a couple more questions.
Yeah,
So your method is called the congruent triangles.
That is the title, that is the title.
Okay, so where are the triangles?
Ah, you have to make them. Forgot to mention.
Okay,
So I have this field.
right.
I realise if you divide it up like this, you get yourself two triangles.
Oh, lovely, lovely. Another question. What does congruent mean?
Another good question, good question. Congruent means that they're the same, you know, they're equal to each
okay.
other. And I had to prove that this triangle was equal to this triangle to prove that they'd be equidistant, so I would dig up the exact spot where my landmines were, in case I dug up a daisy or a buttercup.
You can't be doing that.
You can't be doing that.
I think I might know how you've done it, Wayne.
Yeah?
Yeah?
Well,
so-
firstly I'll ask you a question, just because I'm a teacher, I do that.
Yeah.
Quite inquisitive. So, how do you prove that the triangles are the same? Well, what methods could you use?
Well, there's a few ways, I think.
You're right.
If they're three sides, they're the same as the other three sides. Same triangle, right?
It has to be. If the three sides are the same, they must be the same.
I think you can just sort of add an angle and take away the side each time. I think that's how it works. So you can also have two sides and an angle.
That would work. You have two sides and just the one angle, you can prove that it's the same triangle.
Yeah, then two angles and a side, and three angles.
They all work.
But if yours, Wayne, I think it's two angles and a side. I'll explain mine.
Okay, good.
Right, okay. So, you've drawn a line on it.
Mhm.
That's on both triangles.
Yeah. So,
So
if we
if we-
label them T1 and T2, we're trying to prove that they're equal to each other.
Yeah, that's a good idea.
Okay. T1, T2.
Right. And AC is on both of them, so I think that's what I'm calling the line.
Yep,
AC.
AC, alternating current, I get it.
Right. So I'm going to say that AC equals AC.
And that seems like a silly thing to write, but because it's a proof, you're saying that a line on T1 is equal to a line on T2. It just so happens in this case that the line is actually the exact same line, so AC equals AC. It could well be that there was a really clever diagram and that the lines were equal for some other reason, and they'd be that line equals that line. But it just so happens it's the same line.
Yeah. Now angle time.
Yes.
I've noticed it was a bit like a backwards Z way.
I'll give you that.
And we did some sort of Z angles before. So as this is a Z, I can say that this angle here, which I'm going to call CAB,
Because it goes from C to A to B to get the angle.
will be equal to this angle here, which I'm going to call
A, C, D. It
Yeah.
goes from A to C to D. Now Z angles are in an earlier chapter we did. You can check that out if you don't know what we're on about. But if you know what Z angles are, you can see what Triv did there.
yeah, so they're the same. And they were lovely pointed out by Wayne's walking stick.
Yeah.
But Wayne,
Yeah.
why have you got a walking stick?
It's definitely a relevant question to congruent triangles.
Well, I think it is, yeah.
Still at issue. Q gave me it. It's a gadget, actually.
Gadget.
Yeah.
So
Yeah.
how would you use this one?
Put yourself in this situation.
Right.
You're in Bangalore.
I'm in Bangalore.
You're in the woods.
In the woods.
It's getting quite dark. You're on a top secret mission, but it's getting quite dark and quite cold. So rule
Top secret.
top secret. Shush. So rule 102 is what?
You always set up camp when it's really nippy and get a cup of tea.
You do, because otherwise you'll be in danger.
It saves you from explosions.
Absolutely. So you've got to set up a camp, as
Okay.
you know. You're doing that in that situation.
Mhm.
Suddenly there's a rattling and it leaves ahead.
Oh, okay. Right.
It's just down there. You can hear it. It's
Yeah.
coming closer. Oh, it's a snake. Don't worry about it.
Oh, that was close.
Oh, that was.
Oh, alright. Okay.
So, I don't know what this would have done if there was a snake.
No idea.
So, you see a light down there,
I do.
through the trees, you see it, so you think, I've got a little bit of time.
Now check it out.
Yeah,
Alright.
absolutely. So you waddle over.
Yeah.
This is how you waddle.
I like it.
So, you get to the field.
Right.
Dead serious now. Alright, you go in. There's no one there. Weren't even quite sure where the light was coming from. Perhaps it was just moonlight. Should you set up camp here? When suddenly, all around you is actually people laying down in camouflage. They all jump up and surround you. So you're like, what do I want? What do you want? What do you want? What do you want? What do you want?
But wait. What do they want?
Well, they wanted a submarine. You don't have one of them.
No.
So they break your legs and walk off.
Oh, that's pretty rude.
Turns out it was the moonlight there. It's a beautiful moon.
It's a lovely moon, but so where does that come in handy?
Well, a guy comes in and puts a gun to your head.
Oh, alright, okay.
And he says, have you got a walking stick? And you say, no, I don't have a walking stick. So you both go off and you play golf together.
Oh, that's a really handy gadget for that situation. Like, Q thinks of absolutely everything.
Absolutely everything. It's a lovely golfing session with a friend. Turns out he was another agent.
Was he?
Absolutely.
Oh, how are your legs?
Well, I've got a pandidome. You know, it healed, doesn't it?
It does heal. I think I've sorted out the rest of your question too.
Have you?
Yeah,
Excellent. Let's
right.
carry on.
So we know these two angles are the same. We know these sides. So you've got one side and one angle of each triangle. We need one more angle. Now wait, I've been thinking about the parallel triangles, the parallel lines thing.
Yeah.
So we don't know how long these lines are.
That's why we can't prove that this side equals this side, although they're parallel, they could be completely different lengths.
But the angle will always be the same between these two and these two, right?
Absolutely, because these two are exactly the same in their direction, so are these, so it must be.
Must be. So that means, like my blue pen again, that this angle here,
Yeah.
which I'm going to call ABC,
ABC, that's a good name for it.
will equal this angle here, which I'm going to call ADC.
CDA. Let's go in this way, remember?
Oh yeah, okay, sure. Yeah. So those two things equal each other must equal the same thing, because there was two angles and a side.
By the way,
Yeah.
just realised what you said.
Yeah?
ADC is the same thing. Sorry, I thought you said ABC.
Oh, it's fine, I forgive you.
Yeah, thanks.
Oh, it would have maybe had to be clockwise or something.
No, I didn't want to throw off my student. I realised what you were saying, and I am deeply sorry.
Oh, I forgive you, Wayne.
Okay.
Alright.
So you've got a line and two angles equaling each other.
Yeah?
What should I say? You've really got two lines and four angles equaling each other, really. But
Yeah.
you can do that, so you can finally say triangle ABC must equal triangle ADC.
That really helps you with landmines. Speaking of which, Wayne, I think I found my last one.
Really? Well, where's that?
I'm standing on it.
And on that bombshell, it's time to end.
Is it? Oh, good. Where are you going? Wayne? You need to send for help? What's going on? I need a gadget, some sort of gadget. A walking stick, will that help? I can't reach it. I can't reach it. What am I going to do? It's getting... Oh, come on, I can't set up camp here. Is there lights? Oh, this really does take the